Welcome back. We've cleaned our data and engineered our features. Now, how do we know if our model is actually any good? Today we cover one of the most fundamental concepts in all of machine learning: training, validation, and test sets. Let's start with a problem. If we train our model on some data, and then ask it to make predictions on that exact same data, it's going to do incredibly well. It's already seen all the answers. But this tells us absolutely nothing about how it will perform on new data from the real world. This is the equivalent of cheating on an exam, and it's a cardinal sin in machine learning. The solution is to split our one big dataset into separate piles. The most common and robust way to do this is a three-way split. We take our data and reserve a large portion, maybe 70%, for training. Then we split the remainder into two smaller, equal-sized sets, a validation set and a test set. Each of these sets has a very specific job. The training set is what the model actually learns from. It sees this data and its labels to find the patterns. The validation set is used during development to tune our model and make decisions, like choosing which algorithm works best. And the test set is the most precious. We lock it away and don't touch it until the very end, using it only once to get our final, unbiased performance score. The best analogy is studying for a final exam. The training set is all of your studying, reading the textbook and your notes. The validation set is like taking practice exams. You use them to see what you know and to adjust your study habits. And the test set is the final, proctored exam. You only get to take it once, and that score is your final grade. The whole point of this process is to ensure our model can generalize. We want to be confident that our model hasn't just memorized the training data, but has actually learned the true, underlying patterns. This allows it to make good predictions on data it has never encountered before, which is the entire goal of building a model in the first place. And there you have it. This three-way split is the gold standard for fairly evaluating your models and trusting their performance. But this process can also reveal a common problem. What if our model does too well on the training data, but fails on the test data? In our next lesson, we'll diagnose this exact issue as we explore overfitting versus underfitting.